Premature. Today I'll be going through risk factors for premature mortality in the U.S. First, I want to give an introduction. The objective of this analysis is to understand the oh, oh all right. Sorry, here trying to get myself understand the reading contributions of premature death across the U.S. Also to realize the objective, a secondary health data, specifically the 2017 county health rankings. CHR was used to develop this information. The dataset was chosen for the following reasons: the large sample size, which shows reduce the risk of type 2 errors and enhance the chances of detecting even small relationships between between risk factors and premature death. Low missingness, only a few rows have missing cases, which allow for the list deletion without severely reducing the sample size, hence preserving samples representativeness. And state level observation allow for robust comparative analysis. The data was analyzed and using JASP and R programs. These tools were preferred over the others like Excel and Google Sheets owing to their predictability and handling big data sets that we will be using. First, when I go through my exploratory data, you see below, you see the box plots and scatter plots were used for data visualization. My box plots, both in R and JABS, reveal severe outliers on both predictors and outcome variables. However, these outliers were retained as they were determined to be consistent with response patterns. And you can see the data set here using JAS and the replicator bot plots in R. Next, we'll go through the explanatory data analysis. Scatter plots revealed a linear relationship between the outcome premature death and the predictors using the smoking, obesity, physical inactivity, and uninsured and poor or fair health that people are using in America. In the US, we are one of the worst countries on health. We also use a software comparison in the R program that produce more detailed pairwise scatter plots for exploring relationships, whereas JAS produce cleaner and easier to read plots. As you can see below here, using the R, more data sets are essentially more combined, and then here you can see more of a visual of the actual uh, plots themselves or dots themselves to the actual scatter plots that we use. JAS was a lot cleaner, as you can see below here. Didn't go the right way. The next is my statistical testing, test t-test in R. The research question was, is there a difference in smoking status in Alabama and California? Uh, the test was independent samples t-test, assumption testing. We see Levine's test revealed that there was a quality of means, which was less than 5%. Chaparro with results for Alabama was 97, and using the P was 1179, and California showed 97, and P was 1872. Confirmed normality was achieved. observation were independent, and the results showed that the rate of showed that the smoking is higher in Alabama by 20% than California at 13%, which equaled, oh no, I can't see my numbers below here. Oh, I think I came out of the deck. Oops, sorry about that. Get back into presentation mode. Next is the statistical testing, which did the t-test and JASP. Same analysis was replicated in JASP, although the statistical values were slightly different. The results revealed a similar conclusion. You did see that in assumptions, normality was achieved, showing 0.988, and then P showing 0.379. Quality of variances achieved was 5, with F 1,123 equals to out to 0.6%, and P showed 0.813. This confirms the independent t-test as the appropriate test. As a result, in my results here, you can see that the smoking rate is higher in Alabama, showing at 2%, and then California showed 13, which turned into a 13%, and P was less than 1%. And you can see the actual testing within my JAS system here, showing the smoking and our assumption, and showing the work to break down to show it's less than 1. Going into my modeling and interpretation, multiple linear regressions was conducted to understand the risk factors for premature mortality in the U.S. The predictors accounted for 55.7% of the total variation in the model, R2.557. The model was statistically significant, which was coming out to 772.6, which is less than 1. P is less than 1. The risk factors associated with the premature death were poor and fair health and smoking, physical inactivity, and insured inactivity and being uninsured. Obesity was not identified as a cause of premature death in the U.S. P equals 0.151. Going into the model, the modeling and interpretation, the model was considered to be statistically valid because of the linearity between the outcome and the predictors. Residuals were normality distributed. Plot of residual versus predictor revealed no pattern indicating no homocystic, I'm saying that right, homocysticity, and no multiculinarity was greater than 5. Notably, both R and Jazz yielded identical regressions results indicating robustness and repeated replicability, replicability of the regression analysis across different paths and platforms. Showing a comparison of R and Jazz, side-by-side comparison of R and Jazz in regards to statistical analysis conducted. So the ease of goes and breaks down from on R and Jazz have ease of use, flexibility, predictability, visualization, and output. Now going back and forth in R, required coding, ease of use of required coding, and ease point and click, which is easier in Jazz. Flexibility, extremely high in R, but it's limited to be built in options in Jazz. Reproducibility is great in R, but and it's good, and although it's good in Jazz, but although clicks option makes it slightly difficult. From a visualization standpoint, it's highly customizable in R, decent, but it's less flexible in Jazz. Output and reporting, no publication was ready. APA format tables easier to do in Jazz. Only use R when I feel like you only need to use R when you are comfortable with coding. Otherwise, Jazz was better off for me to use because I'm not the greatest coder. I know I took a lot to learn this stuff in this class, but I like Jazz a little more than I liked R. So conclusion, the smoking rates are higher in Alabama than in California. Poor or fair health smoking, poor health, poor or fair health smoking, physical inactivity, and being uninsured are some of the contributing factors to premature deaths among U.S. citizens. While obesity is a negative health factor, this analysis did not find it as a risk factor of premature mortality. These results were empirically supported, indicating the significance of EDA, statistical testing, and modeling and decision making in that. EDA assesses data quality, ensuring appropriate use of statistical procedures, hence valid results. In the Tukey and Wilk 1966, statistical testing clears hearsay, and from a modeling turns into insight for evidence based on intervention, policymakers, and practitioners. Here are the references I had used throughout this final exam, and that's essentially all I have. I've actually really enjoyed this class. It's been very challenging, though, I will say, and I have learned a lot in my quality management role that I'm in now. The NOVA will definitely help me going forward with statistical analysis. Uh, with that being said, thank you, Professor, and I am going to stop recording. Thank you for your time. Thank you for all the help this semester and your understanding throughout this semester because I had some troubles throughout the year. So with that being said, thank you.